This research has potential to shake up the way we build language model evaluators. They develop a method to improve evaluators with synthetic training data only. So it doesn't rely on costly human judgments or human annotated data. The results are quite promising, to be honest, because they use this method to improve a Llama 370B model on the reward bench, and it went from 75 to 88.3. That outperforms models like GPT-4, and it matches the performance of the top performing reward models on this dataset. As you know, I'm a great believer in LLM evaluators as a scalable proxy for human evaluation of open-ended text generation. We've been relying on strong proprietary models for running this model-based eval for a long time. We've been using GPT-4, Sonnet, etc. However, these models are not specifically adapted to perform evaluations. They are general purpose models with great reasoning skills, but they are not LLM evaluators, right? There have been some previous efforts to train LLM evaluators. For example, Prometheus 1, Prometheus 2, these papers are great. But all of these models, all of the training methods rely on human annotated data or synthetic data creation methods that needed some sort of seed data or human intervention. In contrast, this iterative self-improvement training scheme does not require either human intervention at all or seed data. And I think it really lowers the barrier to training these open and adapted LLM evaluators. One of the coolest things that I found in the paper has to do with how they generated evaluation data. Generating synthetic evaluation data is really challenging, and trust me, I speak from experience. As with many other, let's say, classification problem, you need obviously a balanced data set. In this context, it means that you need to generate both good samples and not so good samples as well. So your evaluator is actually able to assign also like bad scores to those not so good samples. And this is tricky because these LLMs that we use for generating synthetic data have been specifically aligned and trained to provide good outputs that align with user preferences, right? A common approach is to ask the LLM to produce an example of lower quality for a specific instruction based on perhaps a rubric. In this case, the authors took what I think is a different, clever route to generating these bad quality or lower quality outputs. So what they did is, for a given instruction, they first generated the good response as usual, and then instead of asking the LLM to create a lower quality response for the same instruction, they modified the instruction itself. They created like a noisy version of that instruction, and then they generated a response for that noisy instruction. And the idea is that that response to the noisy instruction is going to be a lower quality response to the original instruction. And I think this is really cool because you are actually controlling the quality of the output by applying transformation to the original input. I think it's quite nice.